time to look into PolkaVM, a new smart contracting VM. That is a RISC-V based virtual machine for smart contracts and I think even for parachain verified functions, probably even more. It seems to be really promising technology. So yeah, what I wanted to do, like there's been like really promising benchmark tests that are pretty much stating that it's gonna be 5% faster than Wasm time and 160 times faster compile times. So I think we should find the code and try it out, benchmark it out. It's also stating here that it's running Doom. That sounds like a bit far-fetched from smart contracting VM. I don't think there has been any VMs that level. Well, WebAssembly yes, but it has its own issues, especially with the gas measurement and determinism. Well, let's look. So github.com code PolkaVM get code. Okay, actually have a benchmark going on there. So basically, let's clone it. I have already cloned it. And first thing, what do you want to do? There is no really like in the README. There is design goals, non-goals, and that's about it. There is no really like much of instructions what to do, but like always good tip when it comes to like a new repos that you read. Always check like if there's some workflow, GitHub workflow for installation, because here we can see build on test Linux. So we have like all the dependencies that we need basically installed here. So we need LLD. There is a CI script to execute and install like a RISC-V toolchain. That is a custom toolchain for this VM. And Muzzle, that is a little bit thinner libc. And FreeBSD, that is a Linux alternative, a little bit, well, kind of hardened kernel. Build and test for Linux and check FreeBSD. Well, I have already executed this, so but you can basically run all test or CI jobs, and here you can find to install the dependencies. And we can go to look in the examples. We have hello world. And you can basically execute once you have like installed the dependencies, you can just execute cargo run. Okay, and it's basically executing now the code here. Let's check what is the code, what is we are actually executing. Mine errors. So here we actually find this is like a host function that goes here, and this is the guest function, that is the binary that is going to be executed. And here we define the function name and value for it. It's 100. Instantiate and grab function call and call it. So we have type function add numbers. It basically adds like 3 numbers together. 1, 10, and 100. And I think partially it gets the logic from the guest function that is in the binary. Let's check it out. And say the guest programs example hello world. And I think this is the code for guest function that gets like compiled into the PolkaVM binary. We have a little bit assembly in there. So inside unsafe tags you can write assembly, or you can use actually extern C, that is a C language. So you can even program with the C, Rust or assembly at least for now. And and here we actually see the function add numbers. That is a plus b plus function third number that is in the host function. Okay, cargo run. And when we run it, I cannot execute the binary file. Oh, oops. Okay, well, we have the binary in the output section. So if we check it through, it doesn't make much sense. There is only like 2 function names, and the rest is like this unreadable nonsense for human eye. But if you wanna see what is actually happening on it, it's a instruction set code for a RISC-32, and we have actually a tool here. If we go tools and Polka tool, and we're gonna run it, and we can use 2 functions, link and disassemble, and disassembler, and then we need just to find the find the guest programs output, and we can basically disassemble the binary, and we see what is inside the binary. So here's all the RISC assembler code. This is pretty neat that you can actually see like what's happening on the binary, and I think there is even possibility in the future that we are able to like use this disassembled instructions and translate it back to the original code from the instructions. But right now it's not possible. Okay, let's check the other guest program. Oops, not there, but examples. We have the Doom, and there has been a lot of talk about this Doom. So let's check it out. What's happening here? So we have Doom WAD file, and this is basically the binary. That's basically the code of the Doom. Doesn't make much sense. And then we have Doom PolkaVM binary, that is also nonsense machine code, but full of these instructions, as we see earlier. And then we have the host functions. Then the host functions basically decide the functionality on the host side. So we're gonna make basically the screen appear and the audio to play on the computer here for the Doom. So basically it's getting the program and the ROM, and it's setting background in black, and audio, setting up audio, setting the key bindings, and starting to work on the frames from the binaries on the and I think VM is more or less the same stuff. X output video, X output audio, X from read, X standard out. Set on audio frame, initialize, set on run the frames, graphic frames and key changes. Set functions. Okay. And the key.arrows is probably the key bindings in the keyboard. Let's try to execute it. What happens when we run cargo run release no default features. Okay, let's take a new game. Nightmare, yes. Okay, looks like it has a memory from my earlier try. This is either the COFA not working. Okay. So what happened there was we basically opened the wide file and executed it. All right, that was the Doom. Let's check like a little bit more about the disassembler and let's do the benchmarking result with the PolkaVM. So I have built this like a very simple graphical interface for disassembler for PolkaVM to see like the binary data and ASCII data. What is like ASCII marks there? It just writes a dot if it doesn't recognize it as a letter. And here are the instructions that are usually the dots. That is machine instructions. What happens in the code? I really can't read myself yet this assembler code, but like hopefully in the future I could learn it and maybe build in this graphical interface like way to learn like what these different instructions do. So yeah, it's not perfect as you can see. Let's see. Examples, Doom, ROMs, Polka. So if we open a little bit larger binary, it completely freezes my browser. Okay, looks like we got yeah, it can't really handle this. So yeah, anyways, looks like it manages to load the Doom.PolkaVM to show like content of the Doom, but like I really have not optimized the code, and I think it runs out of memory and other limitations. Like this is just my bad programming. But yeah, it seems to be able to get the instructions out of the Doom binary as well. I wanted to show you the benchmarking tool. It's in PolkaVM tools bench tool. If we run cargo run, it tells us not compiled with profile benchmark, so you need a special profile to run the benchmarks, otherwise the results are gonna be wrong, and that's why there is this flag if you wanna insist. So if you wanna get real results, use this flag. Don't be stupid like I was. And criterion. And that's about it. It takes like about 10 minutes to run. Every test is run with 10 samples, and it shows average, fastest, average, and probably the peak, longest time. Anyways, I have a lot of processes right now, so like a lot of going on different tabs and whatever open, so it's not gonna be good results. So let's check the results I took earlier off camera, and I wrote this script to make them as a graph and post it in the forums. So my computer is 7940 HS laptop processor with 16 threads at 5.4 gigahertz with some NVMe disks. So pretty much latest AMD processor with high performance, and the results are looking really good. So native execution is 2.5 millisecond, and with PolkaVM we are getting like about 1.4x the native execution speed, and compilation speed, well, you can't really measure it to the native, but you can measure it to the other VMs, and other VMs seems to be much slower. Let's say like WASM time is over 120 times slower to compile, and 10 to 15% slower to execute the runtime. So really promising. But yeah, these are like first tests. There has not been like more than these 2 benchmarking tests yet. Let's hope we see more results, but looking promising for this new smart contracting VM. Thank you for watching. Ciao ciao.